Hello and welcome back to Precalculus1. So tonight we have a short lecture on 3.3 properties of logs, and we are going to do the review for exam 2, but it's going to be a part 1 of the review. Then we'll have another review on Wednesday. There will be office hours obviously throughout the week, and then you guys will have exam, I would say. Maybe we can open it on Friday, Saturday, Sunday, something like that. So we'll see how that goes. I will post that in announcements. Let's all talk about first properties of logs. Just a couple of formulas, a couple of interesting things to consider here. And then afterwards we can start a new stream for the review. So properties of logs. What do we have? Well, a couple of things. I am going to write all three formulas at once, and then we're going to do examples, and then we're going to take a look at well, we already did change of base. That one shows up again, and it's very short section. So here are the three formulas that you guys are going to use in Calc 1, and it's going to appear many times later on in calculus and differential equations. So formula number 1 says log of any base of x times y is equal to log ax plus log a y. Formula number 2 is log a x divided by y is log a x minus log a y. And the third formula we are learning in this batch is log x, or log a x raised to some power p is p log a of x. From before, right, 3.2, we know that log base e of x is written as ln x. So all of that, what do you have here? All of these three formulas, right? All of them are going to get the version for ln. I mean, ln is the log, right? So ln of xy is ln x plus ln y. Ln of x over y is ln x minus ln y, and ln x to the p is p ln x. So it doesn't matter, right? Ln is just a special notation for log with the base e, nothing special. So that's what we have. All right, so now let's take a look at some problems with, actually maybe we can, also from before, from 3.2, we know that log of any base of 1 is equal to 0, and log, when the numbers are the same, is equal to 1. And we also have the ln versions. Ln of 1 is 0, and ln of e is 1. So this is what we have in terms of the formulas that we are going to use. But as you can see, there's nothing special. These are the old ones, and these two sets are the same formulas, right? Except the one that it's with ln's. I just want to make sure that it's following the same rule, because it is the same It's log is just the base, right? Is special base E. Well, let's see what types of problems you might run into with these properties. Why do we need these properties, and so on? Well, as it always, right, been, properties are used to do computation. Now we have calculators, computers to do that stuff for us, so we don't care much. But there will be a very powerful differentiation technique in calculus. It will call logarithmic differentiation. And obviously, if you don't know these rules, you won't be able to do that one. Now, that's very powerful and used a lot. And then, you know, the rules are used in other areas as well. But that one is one of the biggest and most powerful uses. All right. So let's say you want to compute log base 2 of, I don't know, of 24, for instance. So what do we do here? Well, I'm trying to see which power of 2 would divide 24. What's the highest exponent of 2? Well, what are the exponents of 2? 2, 4, 8, 16, 32, 64. Right, so which one of these numbers divides, what's the highest number that divides 24? And obviously that's 8. So I can write this as log 2 of 8 times 3. And now, when I rewrite this, I get log 2 of 8 plus log 2 of 3. So I hope you guys see that I used my property, number 1, to break the multiplication in the argument into sum of 2 logs. So now, we can compute this part here. That part is log 2 cubed, and then we still have this one that we can't compute. Now this one is 3, because we said that exponential functions are opposites, right, the inverses of logarithmic. So, but there is now a better way for us to deal with this. You see how there is an exponent? Well, that's our rule 3. This exponent jumps in front. So, exponent jumps in front, and you're left with log 2 of 2 plus log 2 of 3. But this one over here is your log AA formula, and the log AA formula is 1. So whether you're going to use inverse or this, it's up to you. Obviously this is way better. So this whole thing is 3 plus log 2 of 3. Now if you are really in love with decimals, you will use change of base formula to solve that, as you can do ln of 3 divided by ln of 2 to give you some decimals. Now MyMATLAB will tell you whether you are going to keep 2, 3, 5 decimals, so be very careful, because they do mark you off if they say 2 decimals and you put 15. So I'll leave 2 decimals here. So this is now approximately equal to 3 plus 1.58, which is 4.58. So we use the properties of logs to break the problem apart. Now I wrote every single step. Usually people go from here, if they need to write this, to there in one shot. Obviously that's when you practice this and you know what's going on, and you just, do all of that in one shot. So yeah, is it possible? Is it doable? Yes. But as I said, we don't use this for computation because we have calculators, computers. No one cares about this stuff, right? What we care about is decomposing, right, functions, right? We call that expansion. So use the rules to expand. This is the one that it's important for calculus later on. So you're not supposed to forget this. I mean, you can always relearn it when you get there, but whatever. You will use it. Log base 3 of x squared y divided by 4. All right, so I see division. So that's going to be log base 3 x squared y minus log base 3 of 4. So we used rule number 2 that had the division in it to write a log as a difference of two logs. Then I have multiplication. So log base 3 of x squared plus log base 3 of y, and I still have minus log of 4 base 3. And finally, by rule 3, this one jumps in front. That's a rule 3. And then we are done. There is nothing else to do here. Nothing else to simplify. Each log has either one variable or one number. And we are done with the problem. This is expansion. Again, needed for your later calculus experience. Right now, we're only learning the mechanics of doing this. So does it look pointless? And yes, I'll sign that. I have no, right? It's one of those things, look what I can do, right? I would say, you go out with friends and blah, blah, but now I have to say, if you Zoom with your friends or something like that, right? And you can start the whiteboard and just go, say, oh, look, we can do this with logs. Let's take a look at another expansion. Log 6 cube root of x divided by 36y to the 4th. All right, so what do I have? Well, I have a division. So I'm going to do the negative first, right? So I have log base 6 of x to the 1/3. I hope you all know that the cube root is 1/3 exponent. Minus log of 36y to the 4th. Now that's all right, one thing together. All right, so now we kick 1/3 in front. You get your log 6 of x minus, and now this is multiplication. So we're going to put these two, log base 6, I forgot 6 over here, log base 6 of 36 plus log base 6 of y to the 4th. And this minus will now distribute to both terms. So usually, right, mistakes that creep up on exams and so on is you forget to distribute the minus. Because you are programmed, right, by the formula that, oh, it's multiplication, it's plus. Yes, multiplication is plus, and I did put plus, right? But because it was in parentheses, and there was a minus in front, that minus will distribute. So both of these end up being negative. And there is a very simple thing that you can remember. So let's write this log 6 of x minus log 6. Remember that we can write this as a 6 squared. If you can find the same base, that's awesome. And then kick the 4 out. Oh, I forgot to distribute minus. Wow. Minus 4 log 6 of y. For the middle term here, you can either remember that same bases cancel, or you can say drop 2 in front and then log 6 of 6 is 1. So 2 times 1 is 2. But the answer is 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. So one thing that it's important is, and this is one, I'm hoping those of you that are watching and paying attention closely here, observe that what was in the numerator is positive, and everything that it's in denominator is negative. I hope you see that, right? So I have one term in the numerator, and that one term is the only one positive. And I have two factors in denominator. I have 36 and y to the 4th, and both of them ended up being negative. So the number of positive terms corresponds to the number of terms in the numerator, and number of negative terms corresponds to the number of terms, factors actually, in denominator. Let's take a look at more of these now, obviously from homework. So problem 28 says log with the base b of x cubed y divided by z squared. Cross your z's so they're different than 2's, right? Those of you that learned those formulas very well and practiced a lot of problems, right, you can immediately just write the answer, because you know that x and a y that stay within logs will be positive ones, and a z is going to be a negative one, right? Well, let's write all of the steps, but you immediately know that you have 2 positives, 1 negative, and then 3 and 2 go in front. So this literally can be done in one shot, and just write the final answer, because there are no calculations here. So what do I have? I have a log base b of x cubed y minus log base b of z squared. That is going to be log base b of x cubed plus log base b of y minus 2 log base b of z. Rule number 3 takes the powers, kicks them outside. That's what rule number 3 does. So rule number 1 breaks multiplication into addition. Rule number 2 breaks division into subtraction. And rule number 3 takes these exponents and kicks them outside in front of the log. So 3 log base b of x plus log base b of y minus 2 log b of z. So you might ask me, well, how do we know we're done? Well, if you take a look at this log, there's nothing else you can do. It's in a basic form. Remember how we defined log a of b, right? So there is nothing else to do. You just have a log with a base and the value, right? And each one of them is the same. If you take all three, like look at all of these, right? There is literally nothing else. It's a single b and a single z, single b, single y, single b, single x. And you know then you are done. See, there it is, log 6 of x, log 6 of y. Cannot be simplified any further. You reached the end. One more exercise for expansion, and this time we'll take a look at something a little bit spicier, like 38. And this one has ln in it, which is same formula. So ln of x to the fourth square root of x squared plus 3 divided by parentheses x plus 3 to the fifth power. You know that my MATLAB is going to toss out stuff like this, right? They're not going to ask you the previous examples. So to practice this one, all we need to do is to, again, there is a division, so it's subtraction of two ln's. So ln of x to the fourth square root of x squared plus 3 minus ln of x plus 3 to the fifth power. In the next step, we have a multiplication, so we'll have addition of the arguments. So ln x to the fourth plus ln square root of x squared plus 3. Well, square root you can write as a 1/2 exponent minus ln of x plus 3 to the fifth. And now all of the exponents jump in front. So 4 ln x plus 1/2 ln x squared plus 3 minus 5 ln of x plus 3. There is nothing else we can do. We cannot factor this, therefore, I mean, we can factor it, but they're not really looking for it. All right, let's add another line. I was going to say flex over here. All right. No, I'm not going to do it because this is going to factor over complex numbers. It's x minus root 3i, x plus root 3i when you factor it. And then you would have two ln's with the addition, right, for these things. No, I'm not gonna go there. If it was a minus and it just, you know, factored over x minus root 3, x plus root 3, yeah, we can do it. But no need. All right, cool. So we understand, hopefully, that was, what, 5 examples or so? We understand how to compress the logs, expand the logs. So we use the 3 formulas, whether they are red or black over there. So it's a log with base something, or ln, which is base e. It's the same formulas, just notation looks different. So you use them, whatever rules you have to use, until you reach the point where you have only log of a single quantity that you cannot break apart anymore. So now for the first time we had this x squared plus 3 that cannot be factored over real numbers. Therefore, we are not going to break that anymore. We're just going to leave it right there. The next set of exercises are asking us to condense the log, compress the log or condense the log into single logs. So condensing log functions. Now you will say, well, you know, I spoke so highly of the previous one that we'll be using, calculus, Why is this one red? Well, this one is red because we are going to use it here and in calculus, right? The previous one is just, you know, you do a couple of homework exercises, you might or might not get question on a exam, right, for the previous one. And if you don't learn it, you know, it comes back in the calculus, so you have to learn it then. But this one if you don't know how to condense the logs, you won't be able to do the next section. Next section, 3.4, right, needs this. So, needed for 3.4. And calc as well. But next section and the following one actually are both about solving logarithmic and exponential equations. And if you get an equation with multiple logs, first step is to put those logs together into a single log. And the way you do that is by condensing functions. Now, we use the same formulas over here. So we use same 1, 2, 3 formulas. We're just going backwards with these problems. So let's say you have 3 ln x plus 1/2 ln y minus 6 ln z. And you're supposed to condense this into a single log. Need 1 log function. That's what I want. That's my shopping list. All right? So what do I do? So now it's a backwards procedure. So what used to be done last, which is kicking those powers out, that thing is going to be now done first, where you put all of these exponents inside. So it becomes ln x cubed plus ln square root of y minus ln of z to the 6. So the first order of business was to get rid of all of these coefficients. So now all of these are single ln's, right? Now addition of 2 logs condenses it to a multiplication, right, of the arguments. So we have ln x cubed root y minus ln z to the 6. And finally subtraction goes into division, so it becomes ln of x cubed root y divided by z to the 6. And that's the answer. So this skill will be used next class for you to put these logs together into single log so that you can solve equations. Now obviously we'll deal with that when you get there. That will be after exam. So we will be working on 3-4 on Monday and 3-5 on Wednesday next week. And we are done with the material for exam 3. I'm just going to drop this here that there are only 3 weeks left for our course. I thought it was 4 or 5. But there are 3 full weeks and then a week of finals. And the course is over. I was also thinking they will give us an extra week because they wasted our spring break. They extended the spring break, but no, right? So being behind is, I guess, okay, right? So now we don't have time to mess around. I mean, we don't have a lot of sections to cover, luckily. We are going to be able to just cover one thing a day and, focus on reviews and stuff. But hey, can't sit around and relax. All right, let's take a look at a problem from the book. This one has log in it, and it has no base. So now you know what that means, right? Log with no base. Log 3x plus 7 minus log x. So we have to do this, and now it's going to be When we condense this, it's going to be log 3x plus 7 divided by x because it was a subtraction. That's it, just one operation. We have 3 exams plus final, and no project. There will be, we'll have to cut out the project because of the time shortage. I was really hoping for 5 weeks, but there's no 5 weeks. So project will be cut. All right, so let's take a look at a little bit spicier situation. So this is what you can expect, you know, for one of the sides of the problem to look like next chapter. When you have, let's say, 68 is fine. 1/3 bracket 5 ln x plus 6 minus ln x minus ln x squared minus 5. So let's go with calculation here. We are going to say the first thing is to bring all of the exponents in. I just want to make sure that I didn't miss any of the exponents. So 5 and then nothing and nothing. Okay, cool. So what do I have here? I have this one and this one. They're both negative. That means denominator. That's very important. So what I'm going to do is I go 1/3 ln x plus 6 to the 5 minus ln x minus ln x squared minus 5. So now the question about the parentheses. So parentheses are the lowest order, then we have the brackets, then we have the braces. And we can use all of them. I don't have to use these brackets. The book is using them, so I'm copying. I could have just had regular parentheses around. It doesn't matter. But it's higher order, and they're using these because parentheses are used within ln's. All right, time to put this together. So we have 1/3, and now I have a single ln because x plus 6 to the 5 is going to go in the numerator, and then x times x squared minus 5 is going to go in the denominator. You can think about it in two ways. You can say divided by x and divided by x squared minus 5. So just, you know, clear that confusion somehow. There are minus signs. If there is a minus sign is connected to that part where you do the division. So that's the part that we need to understand. And now all I need to do is to bring in 1/3 inside, and that is going to be this wonderful cube root, and we are done. Condensed into a single log, which is, as I said, very important for our next class, which is on 3-4 on Monday, right? So today we're going to do some of the review, and Wednesday's review, Friday, Saturday, Sunday, let's say exam, and the exam is going to be on Canvas, I'm going to import exam into Canvas. You will take exam on Canvas. It will be submitted on Canvas and everything, and then you will look for the grade. Once I post the announcement that it's graded, you go to Gradebook and take a look at the grades. It's going to be simple. All right, let's take a look at another one of these problems. So this is problem 70. That's the last one in the book for these. So log base x plus log x squared minus 4. What's the base when there is no base written? Log 15 minus log x plus 2. So what is the base? Very good. Now, this can be done in one shot. You go and you analyze all of the signs. You say, I have a plus, and I have, let's go plus and plus for the blue ones. So plus and a plus, and then a minus and a minus. So 2 go on top, 2 go on the bottom. So log division line x squared minus 4, 15, x plus 2. Now we're not done, because x squared minus 4 cancels x plus 2. So that's standard trap over here, because that one, see? Dead. So the answer is log base 10, right? X minus 2 divided by 15. So that's what you get when you condense. Cool, huh? Of course, it's math. And now let's just take a look at some cute problems that you might run into, and that's it. They're asking you to use change of base to practice calculating log, I don't know, make up anything, 7 of 132. Now, you can use ln's, or you can use logs, doesn't matter, with base 10. Your calculator has both. So ln 132, close the parenthesis, divided by ln of 7. Most of your mistakes are you don't close the parenthesis. Right? That's the most frequent mistake that you guys make. You do not close the parenthesis after 132, and then you push division and you get a wrong number, right? So you write ln 132, you close the parenthesis, and then you do divided by, and you go on with the rest. So change of base formula, we did that last class. I'm not going to spend time on it now. Let's see what else. They have something cute. I'm not sure if these guys are gonna show up on the MyMathLab. They might. I'm just going to do 2 or 3 examples. True, false. It says on problem, let's say 93, doesn't matter. X log 10 to the x equals x. True or false? So let's take a look what we do here. The first order of business is to kick x outside because that's our exponent, right? So we're going to push that out, and that will create x squared outside, and then you have log 10 equals x. But now we know that the rule is log a of a is 1, so log 10 is 1. We get x squared equals x. False. So that statement was false because, right, didn't work out. Another one of these. This is interesting. 101. Log 3 of 7 is equal to 1 over log base 7 of 3. Well, that one is tricky. So what should we do here? Log base 3 of 7. So think about that one a little bit. How would you approach this problem? There is, the problem obviously here, the big issue, is that the base on one log is not the same as the base on the other log. So is there a way, I don't want to say to fix that, but is there a way, right? And luckily, there is a way to fix that, right? Because we can use change of base formula to put all of this into the common log base and compare them into the common base, right? So use change of base, where log a of b can be written as ln b over ln a, if you like it that way, it's fine. So my log of negative log of 7.3. Not sure what you mean. We're going to write ln of 7 divided by ln of 3 is equal to 1 over, and now I have ln of 3 divided by ln of 7. When you deal with a double fraction, you get ln 7 over ln 3 equals ln 7 over ln 3. So true. All I did is a change of base formula and the left side equal the right side. Woohoo! Right, done in one shot. So that's it. I'm just trying to see if there are any other types of problems, but there's literally nothing else here. We're done with the 3.3. The homework will be open, so you guys can practice the logs. Obviously, you need to focus on chapter 2. Please use study plan to access everything that you need to access, and I will see you in 2-3 minutes. I gotta restart all of this stuff now.